Good morning students. In the previous session we discussed about some problems related to geometric progression. So in this class also we are going to solve some problems related to geometric progression. So first problem is, so find the sum of the following GP. So first question, 1 by 4, 1 by 16 etc. up to 5 elements. So here we want to find out sum of first 5 elements of the given sequence. So we know the formula to find out sum of n terms of the given sequence is Sn is equal to, so here it depends on the value r. Suppose if r is less than 1, then Sn is equal to a into 1 minus r to the power of n divided by 1 minus r. Suppose if r is greater than 1, so then Sn is equal to a into r to the power of n minus 1 by r minus 1. Okay, so here first let us find out values of a, r and n. So using the given sequence. So a means first term is 1. So a is 1, r means common difference, second term divided by first term. So 1 by 4 divided by 1. So 1 by 4 by 1 is 1 by 4. This is less than 1. So r is less than 1. So up to n term. So 5 terms. Therefore n is equal to 5. We want Sn or S5. Sn or S5. Sum of 5 terms. So consider the formula. Sn is equal to, here r is less than 1. So a into 1 minus r to the power of n divided by 1 minus r. So now substitute the values of a, r and n. So a means 1. 1 into 1 minus r means 1 by 4, 1 by 4, o to the power of n means 5, divided by 1 minus r means 1 by 4. Okay, next simplify. So 1 into 1 minus 1 by 4 o to the power of 5 divided by 1 minus 1 by 4 is 1 minus 1 by 4 o to the power of 5 divided by 1 minus 1 by 4. Okay, so this came written as 1 minus 1 to the power of 5 is 1, 4 to the power of 5. Whole thing divided by, yes, subtract these two terms. So LCM is 4, 1 into 4, 4, 4 minus 1, 3. So 1 minus 1 by 4 is 3 by 4. Okay. So next, therefore Sn is equal to, here subtract these two terms. So LCM is 4 to the power of 5. Next multiply each term by 4 to the power of 5. So 1 into 4 to the power of 5 is 4 to the power of 5 minus 1 by 4 to the power of 5 into 4 to the power of 5 is 1. Okay, next divided by 3 by 4. Take this term into numerator. So 3 by 4 it becomes 4 by 3 into 4 by 3. So 4, here we have 4, 5 times, 1 times get cancelled, remaining 4 times. So next simplify. Sn is equal to 4 to the power of 5 is 1024 minus 1 divided by 4 to the power of 4 into 3. So 1024 minus 1 is 1023 divided by 4 to the power of 4. 256 into 3. 1023 divided by 256 into 3 is 768. Next divide these two terms by 3. So we get 341 here 256. Therefore Sn is equal to or S5. S5 is equal to 341 divided by 256. So therefore required sum of first 5 terms of the given sequence is 331 divided by 256. Okay. Next let us move on to the next problem. Next problem, second one, -2, 4, -8, etc. up to 8 elements. So here we want to find out sum of first 8 terms of the given sequence -2, 4, -8, etc. So here also use the formula Sn is equal to A into 1 minus r to the power of n divided by 1 minus r, or Sn is equal to A into r to the power of n minus 1 divided by r minus 1. So it depends on r. Okay, so first let us find out values of A, r and n. So A means first term -2, r means second term divided by first term. So 4 divided by -2 is -2. R is equal to -2, so less than 1. So n means 8. So we want S8, sum of 8 terms of the given sequence. So S8. So now consider the formula Sn. Sn is equal to A into, here r is less than 1. So therefore formula 1 minus r to the power of n divided by 1 minus r. So we want S8. So substitute here. A means -2 into 1 minus r. R means -2 whole to the power of n. N means 8 divided by 1 minus r. R means -2. Okay, simplify here. -2, 1 minus minus to the power of 8 is plus, so 2 to the power of 8 is 256 divided by 1 minus into -2 plus 2. So it's equal to -2 into 1 minus 256 is minus 255 divided by 3. Therefore S8 is equal to -2 into minus 255 divided by 3 is minus 85. So minus into minus plus, so 2 into 85 is 170. Therefore S8 is equal to 170. Therefore required sum of first 8 elements of the given sequence -2, 4, -8 is 170. Okay, next problem. So next problem is third one, 0.1, 0.3, 0.9 up to 10 elements. Up to 10 elements. So means we want here S10. So A means 0.1, R means 0.3 divided by 0.1 is equal to 3 is greater than 1. So n means 10, we want S10. So here R is greater than 1, therefore consider Sn is equal to A into r to the power of n minus 1 divided by r minus 1. So now substitute the values of A, R and n. So A means 0.1. 0.1 into R. R means 3. 3 to the power of n. N means 10. Minus 1 divided by R means 3. So 3 minus 1. So 0.1 into 3 to the power of 10. is 59,049 minus 1 divided by 3 minus 1 is 2. Therefore 0.1 into 59,049 minus 1 is 59,048. So divided by 2. Therefore S10 is equal to 0.1 into 59,048 divided by 2 is 29,524. So 0.1 into 29,524 is 2,952.4. Therefore S10 is equal to 2,952.4. Okay, next let us move on to the next problem. Next question, find the sum of n terms of the GP. So sub question, first one, 5 plus 55 plus 555 to infinity. So here we want to find out sum of n terms of this series. So let sum of n terms of the series is by Sn. We want 5 plus 55 plus 555 up to n terms. So here observe, this series is neither in AP or GP. So first convert this series into GP by follow the following procedure. So first take out here 5 as the common term. So write Sn as it is, take out 5 as the common term. We get here 1, this is 11 plus 111 up to 10 terms. Next, take this term into left side. It becomes Sn by 5 is equal to 1 plus 11 plus 111 up to n terms. Okay. Next, multiply whole equation by 9. So 9 Sn divided by 5 is equal to, here 9 into 1 9 plus 9 into 11 99 plus 9 into 111 999 up to n terms. Okay, next 9 Sn divided by 9 into Sn divided by 5 is equal to, so 9 can be written as 10 minus 1 99 can be written as 100 minus 1 9 here 9 can be written as 10 minus 1 99 can be written as 100 minus 1 999 can be written as 1000 minus 1. So 10 minus 1, 9 can be written as 10 minus 1, right? 10 minus 1 plus 99 can be written as 100 minus 1, 100 can be written as 10 square. So 10 square minus 1. So 10 square minus 1 plus 999, this can be written as 1000 minus 1. So 1000 means 10 cube. So 10 cube minus 1. 10 cube minus 1 up to n terms. Up to n terms. Now separate here 9 8 Sn. 9 into Sn divided by 5 is equal to, so separate the terms here 10 square 10 cube and minus 1. So 10 plus 10 square plus 10 cube up to n terms, minus 1 minus 1 minus 1. So in these terms take out minus as the common term. Therefore we get 1 plus 1 plus 1 up to how many terms are there here? N terms. N terms. Now simplify here. Here observe 10 square divided by 10 is 10 cube divided by 10 square is 10. So ratio is constant. Therefore this series is GP. So to find out sum of n terms here, So consider the formula Sn. Sn is equal to here. R means 10. So R is greater than 1. So consider the formula here to find out sum of these terms. A into R is greater than 1. So consider A into R to the power of n divided by R minus 1 here. So write 9 Sn divided by 5 is equal to, so here formula A into R to the power of n minus 1 divided by R minus 1 minus of 1 plus 1 plus 1 n times. So n terms. Suppose if we consider 2 terms, 1 plus 1, 2. Suppose if we consider 3, 1 plus 1 plus 1, 3. So suppose if we consider 4 terms, 1 plus 1 plus 1 plus means 4. So here we consider n terms means n. So 9 Sn by 5 is equal to, so in this series A means 10, R means common ratio, 10 square divided by 10 is 10, 10 to the power of n minus 1 by 10 minus 1 is 9 minus n. Now we want Sn, so cross multiply here. So 9 by 5, take this 10, take 9 by 5 into right side. So we get Sn is equal to, cross multiply here, 5 divided by 9. 5 by 9 into 10 into 10 to the power of n minus 1 by 9 minus n. So this is the required sum of the terms 5, 55, 555. Okay, next problem. So next question, 0.3 plus 0.33, 0.333 up to etc. So here also follow the same procedure. So here we want to find out sum of these these terms. So let this sum is equal to Sn. So first convert this series into GP. So 0.3 can be written as 3 by 10. 0.33 this can be written as 33 divided by 100. 0.333 can be written as 333 divided by 1000 up to n terms. We want sum of n terms. So consider up to n terms. So now take out 3 as the common term here. So remaining terms are 1 by 10. Here 3 is common. Remaining terms here 11 by 100 plus here 111 by 1000 up to n terms. Okay. So next take out 3 into left side becomes Sn divided by 3 is equal to 1 by 10 plus 11 divided by 100. 100 can be written as 10 square plus 111 divided by 10,000 can be written as 10 cube up to n terms. Okay. Next multiply whole equation by 9. So we get 9 Sn divided by 3 is equal to 9 by 10 plus 9 into 11, 99 by 10 square minus 111 into 9 means 999 divided by 10 cube up to n terms. Okay, next here 3 3s are. So 3 Sn is equal to 3 Sn is equal to, so 9 can be written as 10 minus 1. So 10 minus 1 divided by 10 plus 99 can be written as 100 minus 1. So 100 minus 1, 100 can be written as 10 square. So 100 minus 1, 100 can be written as 10 square divided by 10 square plus 999 can be written as 1000 minus 1. So 1000 can be written as 10 cube, 1000 minus 1 divided by 10 cube up to n terms. Next 3Sn is equal to 10 by 10 is 1 minus 1 by 10. Split the denominator to each term here. So 10 square by 10 square 1 minus 1 by 10 square plus 10 cube by 10 cube 1 minus 1 by 10 cube up to n terms. Now separate the terms containing 10 and 1. So 3Sn is equal to 1 plus 1 plus 1. How many terms are there? N terms. So here minus 1 by 10 minus 1 by 10 square minus 1 by 10 cube. Take out minus as the common. So 1 by 10, 1 by 10 square plus 1 by 10 cube up to n terms. So next 3Sn is equal to 1 plus 1 plus 1. So total n terms means n minus. So here observe this series in GP. So 1 by 10 square divided by 1 by 10 is 1 by 10. 1 by 10 cube divided by 1 by 10 square is 1 by 10. So R is 1 by 10. So this is less than 1. So therefore consider formula A into R is less than 1. So 1 minus R to the power of n divided by 1 minus R. Okay. So n minus, so 3Sn is equal to n minus. So here A. So in this series A means 1 by 10. 1 by 10 into 1 minus R. R means it is also 1 by 10. 1 by 10 O to the power of n divided by 1 minus R. R means 1 by 10. Okay, next simplify. 3Sn is equal to n minus 1 by 10 into 1 minus 1 to the power of n is 1, 10 to the power of n divided by 1 minus 1 by 10. So 10 is LCM, 10 minus 1 is 9. So 9 by 10. So next simplify. 3Sn is equal to n minus 1 by 10, n minus 1 by 10. Take this term into numerator, 9 by 10 it becomes 10 by 9. So 10 by 9 into 1 minus 1 by 10 to the power of n. 1 by 10 to the power of n. Here 10 get cancelled. Therefore Sn is equal to cross multiply here. So 1 by 3 into n minus of 1 by 9 into 1 minus 1 by 10 to the power of n. So this is the required sum. Okay. So next let us move on to the next problem. Next problem. How many terms of the GP? How many terms of the GP? 1, 3, 9, etc. will amount to 364. Okay, here we want to find out how many terms are required to make the sum 364. Means here we want to find out value of n. So using the given conditions. So first let us find out values of A, R and here we want to find out n. So first let us find out values of A, R and Sn. So using the given sequence A means 1, R means 3 by 1, so that is 3. 3 is greater than 1. So we want n. So here Sn is 364. Sn means 364. Therefore consider Sn is equal to, here r is greater than 1. Therefore formula a into r to the power of n minus 1 by r minus 1. Now substitute the values of a and r. Sn means 364. A means 1 into r means 3. So 3 to the power of n minus 1 divided by r means 3. 3 minus 1. Next 364 is equal to 3 to the power of n minus 1 by 3 minus 1 is 2. Next cross multiply here. 364 into 2 is 728 is equal to 3 to the power of n minus 1. Next take this term into left side. 728 plus 1 is equal to 3 to the power of n. So 729 is equal to 3 to the power of n. So 729, this can be written as 3 to the power of 6. So therefore there implies we get n is equal to 6. So therefore 6 terms are required to make the sum 364. Okay. So next let us move on to the next problem, similar problem. Next question, similar problem. How many terms of the GP 1 by 2, 1 by 4, 1 by 8, etc. will amount to 31 divided by 32. Okay, so using the given sequence we get A means 1 by 2, R is equal to second term is 1 by 4 divided by first term. So first term is 1 by 2. So 1 by 4, take this term into numerator, it becomes 2 by 1. So 2 1s are 2 2s are. So 1 by 2. R is equal to 1 by 2 less than 1. So we want n value. So let Sn is equal to 31 divided by 32. Now consider Sn is equal to A into, here R is less than 1. So formula A into 1 minus R to the power of n divided by 1 minus R. So Sn means 31 divided by 32. Divided by 32 is equal to A. A means 1 by 2. 1 by 2 into 1 minus R. R means 1 by 2. 1 by 2 whole to the power of n divided by 1 minus R means 1 by 2. So 31 divided by 32 is equal to 1 by 2 into 1 minus 1 by 2 whole to the power of n divided by 1 minus 1 by 2 is 1 by 2. So here 1 by 2 get cancelled. Okay, next simplify. 31 divided by 32. 31 divided by 32 is equal to 1 minus 1 by 2 whole to the power of n. So 1 by 2 whole to the power of n. So take this term into left side. Minus 1 by 2 whole to the power of n, it becomes plus 1 by 2 whole to the power of n is equal to 1. So take this term into right side, becomes minus 31 divided by 32. So therefore 1 by 2 whole to the power of n is equal to, so subtract these two terms. So LCM for 32 and 1 is 32. 32 into 1, 32 minus 31 divided by 32 into 32. So 32 get cancelled. Remain term here 31. So 1 by 2 whole to the power of n is equal to 32 minus 31 is 1. 1 divided by 32. So 1 by 2 o to the power of n is equal to 1 by 32. 32 can be written as 2 to the power of 5. So this can be written as 1 by 2 o to the power of n. So 1 can be written as 1 to the power of 5. Therefore this can be written as 1 by 2 o to the power of 5. So there implies we get n is equal to 5. N is equal to 5. Therefore 5 terms are required to make the sum 31 divided by 32. Okay. We will continue in next class. Thank you.